All right. Let me check the audio. That looks like it's working. Just a second here. I guess I was looking for a easy way to get the link shared in Discord, and I'm not seeing it. So mildly annoying. Okay, I found it. All right, get shareable link. Let me post this to Discord and then I'll jump in. Um, all right. So it actually is useful to like so this is a reader's code that is the it is the Dominion of Kings challenge, but with methods. And so they're trying to like do some fancier things with it, which I think is fantastic. This is the exact kind of like tinkering and exploration that I hope readers do. And it doesn't have to be to revisit challenges in the book. Um it could be to just try your own stuff. Like I do hope that people are getting more practice than just straight up what's in the book, because I think that that's how you really learn, is to have, to start with like structured, like here's the thing, go do it, and then to like start to explore a little more on your own, a little more free form. I think that's a really good thing to do. I love that this person has done this. So if you've done this challenge, like, so so this is, and if people didn't notice the reference, this is essentially totaling up your points in the card game Dominion. That's why it's called the Dominion of Kings. But anyway, so we have estates, duchies, provinces, and you're supposed to tell how many there are. We added the value. Every province is worth 6, every duchy is worth 3, every estate's worth 1. So 6 times 4 is 24, plus 3 times 1 is 27, plus 5 is 32. So they've approached this two ways. We'll look at that code in a second. But we're displaying this again, and then it's giving us the option to like buy a card. Um, and I was a little, when I did this here, I was a little confused about how to choose something. So like from a user experience design standpoint, maybe it left a little to be desired. I was like, what do you want to buy? And I'm like, I don't know. Do I type in the number? But so I typed it in. I was wrong. It gave me good feedback. Incorrect option. Please choose a state, duchy, or province. Then I knew what I was doing. It told me, it gave me the result again. What card do you want to buy? And I typed it in. Uh, Choose, and then it asked me how many I want. Choose between 1 and 10. I said 4. You purchase 4 provinces. So in theory, my province count should have gone up to 10, and I should have gotten an extra 40 points. I didn't. That's okay. Not a big deal. But maybe we'll fix that. Maybe we won't. I don't, let's see. We're already almost 5 minutes into this. There's some interesting stuff here in terms of like methods and like reasoning about methods. The person mentioned spaghetti code. And so I want to, I want to just kind of go through this. Like, so starting here at the top, like this is good. I like it. This is like, in the future, like we haven't covered this at this point, but like this is a good place for consts. Um, we haven't covered that at this point in the book, so it's fine. C sharp, I don't 11 or 12 added in this thing where you can do it this way. Not that, I mean, given how this is, I don't know that this is that much better, but like I might do that. I don't think like what was here was just fine. It totally was. But I do like the array, the collection expression where you just do square brackets to put your stuff in. Um, and it figures out what type you meant by inferring it from this side. This get card values. So, get for, okay. So this is the first place so let me put it this way. Methods each have their own little container. Like every method gets its own little container for variables. And anytime a method begins, its little like box, its container to put its variables in, gets created. And in general, every method that is currently running, like they have their own little pile of data that the other methods that are theoretically still running, like for example, from the main method, what we call into get card values. Theoretically, each like this get card values doesn't access the original method's memory, and the original doesn't access this method's memory. That they're independent, which is for the most part, like that's a good thing that they all have their own independent memory. Because for the most part, it means that when I'm doing something within one method, I can't mess up any other method. And that other method, like when I call another method, that method won't mess up my stuff. They're all independent, and that makes it easier to reason about because I can think about just the context of like a single method. Like if I have like a public, not public, void get and add two numbers, and then I just do like int a equals console.read line, and then let's throw in a convert dot to int 32, or if you want int dot parse, you can do that, and then I can do b, and then I can do console dot write line a plus b. So oops, something like that. Like I have my own data, and I know that even when I call console.readLine or call convert.toInt32 or console.writeLine, like none of these other methods that I call are going to be able to mess with my data. So I don't have to worry, like it just does its thing, and I know my data's safe. Similarly, I know that like I'm not gonna accidentally interfere with somebody else's data, and that means that like when I'm working on it's this concept of abstraction, which the book covers in more depth, especially in the context of like classes later in part 2. But when you're in here and you've got a method like this that like you can, when you're on the outside of the method, like when we do this console.readLine, I don't care how it does it. It's irrelevant to me how it does it, just as long as it does its job. So I don't have to think about those details. Meanwhile, when I'm inside of a method working on it, like I don't have to be thinking about how the rest of the world works or how I might be interfering with the rest of the world. And those qualities are really good and really important because that means that I can work on things in little teeny chunks. Like I can work on this get and add two numbers method, and like if I decide I want to make a change to it, I know I can make changes here, and as long as I don't change how the rest of the world interacts with this, I could do whatever I want on the inside, and nobody, as long as I still fulfill my end of the bargain, getting and adding two numbers, as long as I fulfill my end of the bargain, nobody's going to be impacted by me making a change. Like, and I mentioned this, like int dot parse, like if I said I wanted to do that instead, like nobody, like I can work on this, and I like the extent of my changes are very small. When you have a tiny program, and I'm going to be honest, 118 lines of code, this is a tiny program. The person who wrote this, in fact, other readers who are kind of like at this late in part 1 might look at that and feel like, wow, this is quite a bit of code. And by comparison, it is. But it's definitely like when I talk about long code and like how do you manage long bigger programs, like we're talking, 10,000 lines of code, 100,000 lines of code, millions of lines of code, like it gets much bigger. And to have this ability to just go into a single method or a single class, which we haven't gotten to yet, but go into a single one of these, and to be able to feel like you can make changes to it while knowing you're not like nothing else in the world is going to be affected by it, is a really good place to be. I will say that obviously there are going to be times where the intent of a method is to affect things that other people are dealing with. And in those cases, like it's a different scenario. But for the most part, if you can have a method that is independent of everything else, or to the extent that you can make a method independent of everything else, you're in better shape. The way that a method communicates with its caller is by parameters and return values. And if you use just those to communicate, it's like that puts you in a pretty good place in terms of like being able to change things. So if I wanted to make this an int method to like return that result, like I can just say return a plus b, then now I can communicate back to the caller of what their end result was. So when I use it now, I can just get this result and do something with it. All right, so so some of this, like the person's concern was just that it kind of felt like things were intertwined, spaghetti. Part of that is that a lot of these methods are doing something that methods in general don't do, which is accessing the they are accessing the data of their container method. So if you like structurally, the way this code works, this is your main method starts here at the top and goes all the way down until, well, really the end of, until you define a type, which we don't define any. So it comes all the way down to here, except that these methods, buy cards, get card values, get kingdom in value, get kingdom value. These are like, they live underneath the main method. So these are like, they're called local functions. They're a type of method that lives inside of another method. And so, I mean, same thing. Like I could take this method and I could stick it right in here. And I could take this method and I could stick it right in here. Not that I want to do that. So now I have a method inside of a method inside of a method inside of the main method. So like you can put methods inside of methods. Let me back up here. I don't actually want to do all that. But so the point is that this particular setup, when you have a method inside of another one, the inside method can borrow method parameter or local variables, like these variables in another method, which is a separate mechanism than the quote unquote normal thing to do, which is parameters and return values. So we can like kind of just steal the memory and just use it and do whatever we want with it. And there's a time and a place for that. There's a, like, that can be really powerful, but we at least want to be able to do stuff without, like I said, this is the problem, is that when I do that, now I'm tied to a very specific usage of things here. So these card values, these card types. So just looking at this, I actually think that method is, I would consider it misnamed. I think, because I think all this does is it, like this says get card values. I think I would it just iterates through these and just displays them. So I think what I would do is I'm going to rename this. I'm going to refactor this, but Control R, and then I release the R. Control R is pressing for the same key. My pinky is still on the control key. My pointer finger, I pushed R temporarily, and then I released it. And now I'm going to put it back on R. So it's Control R, but you don't release the control key. It's a multi-part shortcut. And now it comes up with this refactor menu. By the way, you want to do it the hard way. It's in here somewhere. Rename. Control this guy right here. Hard way. That's not that hard. But so display card values. Oops. I feel like that's a better name. Now, so if I wanted to make this less, so like the problem here is that this is using the main method's memory, the main method's variables. And again, this can be the right choice, but you want to at least consider what it might look like to do it otherwise. And I think the easiest way to do that here would just be string options. So we just pass in the options, and then of course I gotta, let's see, then I gotta come up here and pass in card types. And then apparently over here, so I can fix it that way, but notice that now I've made, so this is a reference to the card types. That was the main method. So this is now a local function that's taking its parent, the main method's variable, and passing its contents into display card value. So maybe we'll deal with that in a minute. Maybe we won't. But so now in this case, this will just display these options in here, which I think is good. And without using that, like, it's now separated. The only data it's using is its own data and the parameters that it's been fed when it's called. And the advantage of this is that now I can use this method in more places than, like, it's a bit more flexible. So before, like, if I said, well, you know, in the first place I wanted to do estate 1, duchy 3, province 6, I can definitely display that. But for example, if I come down here where I was calling that in the other place, if down, let's see, where was that? Was it this guy? I think it was this guy. If I wanted to, like, display something else, like that, a comma, I can do that. So now I'm passing in something different. So this method now has more flexibility because I can call it with different things in different circumstances. I'm not always tied to that. The downside is when I call it, I have to pass in a value, right? So here I had to pass in a new array with specific values. Up here I had to pass in card types. With the way it was before, where I just used that variable, I didn't have to pass it along. I didn't have to, you know, send the data that's in card types into the other method. It just found it on its own. So those are trade-offs, and that's a pretty typical thing in software development, is the trade-offs. You know, what are the pros and cons, and which set of pros do you want, and which set of cons are you fine living with to get those pros. So but I do think, like, that type of thing helps. Certainly I think it's worth, like, understanding what the option looks like so that you can make a decision knowingly whether you want one way or the other. So, and now this goes through and it says, you know, how many estates do you own? How many duchies do you own? How many provinces do you own? I might make an argument that this might be a good place for another method to do something like, and there is a challenge in the book that's like, so if I take basically this code and stick it here, and then I do that, and then I just I can just say return what I get out of that. And then right here I can do something like our total estate equals ask for number, and I don't know if that makes a huge difference, but, like, maybe, I don't know. Like, it kind of does, in the sense that, like, it's less code to think about. And if I do end up doing something like just looking way down the path, like, again, if I say I'd prefer to use int.parse, like, now I can make that change, and I changed all 3 of those places instead of, like, having to change it 3 different times. But there's also this option to, like there's int.try parse, which I don't want people to, like, and like, But like this it has an output parameter which is more complicated. Like I don't people shouldn't do this, but the idea would be like the nice thing about try parse is that it'll tell you if it succeeded or not. And so somebody types in garbage, like not a number, this code will still work. All right, if you use try parse, it's just I have said this to a lot of readers. At that try parse is covered in the book, just in part 3, and until then, I wouldn't worry too much about input, like handling every possible scenario, because we don't have all the tools, and B, the stakes are low, and C, like the main point right now is to use methods and trying to learn how to create a class and trying to learn how to do like loops and arrays and if statements, and like that's what's interesting right now, not handling every possible way that the user could mess up our input. So I wouldn't worry too much about handling all possible ways that input could be bad. Um, it's certainly not at this point. Even in real life, even in like production, it depends on the stakes. Because if you're writing a little tool that just is supposed to help you do something, like for example, compute your score in a game of Dominion, you don't really need a whole like you don't need to like necessarily go out of your way to handle all forms of bad input. You can probably be pretty casual about it because worst case scenario, it crashes and you have to start over and you are the only user and you'll just do it better next time, right? So the stakes are low. So it's not something I'd worry about too much. But of course, if you're like, well, I'm going to make an app that I sell in the App Store, and like I hope millions of users download this to compute their score in a game of Dominion. Um, in that case, you don't want that app to just crash. Of course, at that point, maybe you're talking about holding up your camera above all of the stuff in front of you and having it just analyze all the pictures and figure out how many of everything you have, including how many curses you have and how many of all the other weird victory. Are they called victory points? Whatever it is. Anyway, so the point being, like, if we make a method like this, it does reduce the amount of like work we have to think about if we want to change something. Not that we're going to, but it also the main thing here is like now I have a tool that allows me to ask for a number without having to understand the specifics of what that might be. We've hidden complexity, and that's important. In fact, that is the main purpose of having a method, not so much about removing like duplicate code, though that does play a role. But the point is it's okay to have a method even if you only use it once, as long as it's providing some sort of value of like hiding complexity that you don't necessarily want to look at. All right, so we've got that, and now here we total up the score. So there's two of these. So there's get kingdom value and get kingdom int value. One of these returns an int, and so again, like this just passes in these parameters from the main method. Like, and so here's a trick. It's not really that much of a trick, but if you keep realizing that you're borrowing the variables from your main method, from the container method, if you put a static on here, it will stop you from doing that. It'll turn these into compiler errors. By putting static on here, you're saying I'm independent. I'm not expecting to use anything that is part of the container. And by the way, static is used for slightly different things in other contexts. So, but yeah, so in this context, that's what this is saying. I like I like it's like you can see that here, like this is using those pretty heavily. If I do it here, I'll see the same thing. And I think that like, so one thing we could do, like this estate points, duchy points, province points, like one thing I kind of wonder about here is what if we did this math inside of these two methods, right? And ultimately the intent isn't to have both of these. These are just an experiment by the original reader to figure out like how to work type and versus methods that are void. All right, I promise no more than 5 minutes on this, and then I'll be done. But yeah, so what if we just move this logic inside of there? So we come in here, we put this here, and so now I've declared these variables here, which by the way, I'll do the same thing in here. And now, so total is, sorry, it's these point values. I'm going to move these also into here. And again, like, yes, it's showing up in two places, but the intent wouldn't be to have both of these. The intent would just be to have one. And now we have like these total things. If we remove the static, this will still work. It can still borrow, like steal them from the main method. But what I'll do here is I will do int estates, int duchies, int provinces. So we're going to use parameters to like pass this stuff in. I'm going to do the same thing down here. And then I'm going to do that. So now we just pass that stuff in, which means up here we got to pass this in. So estate, total estates, total duchies, total provinces, which is also what we need to do down here in this version. And so it feels like we're actually doing this math 3 times over. Like there's this int kingdom value that is the return thing. This is used here. Is that used anywhere? I don't think that's used anywhere. I didn't see it. Oh, right there. Okay, so it's being used down there. But that's part of this other stuff about like being able to buy cards. So I'll leave that alone. Well, okay, I'm not gonna leave that alone. I'm gonna delete it. However, what I'll do here is I will do this. I'll say, let's see, total int total kingdom value equals so again, like the trade-off here is I have to pass in 3 parameters versus before I didn't have to actually pass in parameters because it was just stealing them. It was just sneaking behind the scenes and grabbing them. And the compiler, by the way, is doing like those variables are no longer just like normal variables. The compiler moves them over to another location. It's called like a closure. It's this other like chunk of memory. It's an object if you're that far along in the book. It's an object. It's called a closure, where these variables that are it's called capturing the variables. These captured variables get moved to a different location, and then both of your methods kind of get reworked to access them through the closure object. So we're avoiding those, which is probably a good thing too. But anyway, so now I've got this, and I could probably do this right here. And then let's see. Oh, okay, so maybe they're okay. The benefit of where we had these before is like now as they change, like all these things reference the same stuff. And since I moved those definitions into that other code, I've lost that. I'm gonna so maybe there's still value in having those like constants defined up there. But yeah, here we are. So so yeah, this is the one version of like computing all of this using the version that returns an int. And then, and at this point I can remove that static again. Same with this guy. And then right here, now we pass in this stuff and this just does it and displays it. It doesn't return it. So that's the difference between these two. I personally like this version better. Like I like that we have code that just computes the total like points, and then when we want, and then handling the output separate. So I like that better. I might just do like, we don't need to put this in a variable, This is and the person whose code this is and I had a conversation. But I do want to mention this for other people. The When we say like return a value like this, we are not we're not returning the variable itself. Like we're not, again, the memory, this memory for this method, once I hit that return and leave the method, that memory is gone. Um, the memory comes into existence when I start the method, including the memory for all of the parameters and local variables, local variable, and then it disappears when we exit the method. So the memory comes and goes, but what survives is not the memory itself, but the content. In this case, we're returning a value. So there's a specific value, which happened to be something that was stored in this variable temporarily. That's what sticks around just long enough for the caller to like decide if they want to do anything with it. So I might just not have that local variable. I might just do that and then so just return it directly. Like it's just as well to return a specific, any other expression. It doesn't have to be a variable. Sometimes it makes sense to have that variable. Like you're totally allowed to store it in a variable if giving it a name adds value or helps you for other reasons. In this case, I didn't feel like it helped. So I do like this, and I like that better than this version. This version's fine. But I feel like this gives us more flexibility because we can use this in a way that isn't just that it doesn't demand we then display the results immediately. So we split up two things that might be used for different reasons. Computing the score and telling the user what their score was are now can be separate things. So I actually like this version that returns an int better. So I'm going to actually delete this. I'm gonna I better do some cleanup up here. But so then I don't need this version, and I'll just simplify this to your kingdom's value is that, and then I'm gonna just rename this guy to get kingdom value. Yeah. So I could spend a little more time here with this buy cards. I think the only real like I think this code's pretty good. I do think, again, like if we mark this static, you'll see like this is using these other things. Oh, including it's using the static, and then how that work. Yeah. So the static stuff can't access non-static stuff. But if I do that, I ought to be able to see if I'm accessing. Yeah. So I'm modifying these down here. And so again, like I might not like I think this code is pretty good. I like it. One thing I might do is so like this as like while not valid choice, like for me, valid choice. No. Okay. Like for me, sometimes it's easier to rather than like initialize this here and then like set it here. Like, because one of the problems is sometimes down in here you'll have other code here, like you have other code down here. And for me, a lot of times it's easier to reason about this by just letting the loop just loop forever. Asterisk. It won't loop forever. We'll escape the loop at some point. But what I'll do here is this. So when we do find a valid choice, we'll break. So this is how we'll get out of the loop. And that makes it easier. Like we don't have to have this same check there and there, nor do we have to have that extra variable. Like once we detected that everything's good, then we just go on. And so at this point, I don't need this, like the else doesn't matter anymore. It will, that's what it'll just do automatically. So I feel like for me, I like this approach better. Like a while true, or sometimes people will do, I like this a whole lot less. But that code, some people love that. It's the exact same thing, like an empty for loop. For me, this conveys the intent a lot more specifically. but do what you like. But yeah, so for me to run it this way, I like that better. And the same thing goes here as well. So by the way, some here it's not, but like sometimes um I can also then like move this into here. Like this actually works other than I need that choice later down here. So I can't get away with simplifying that. It's fine like this. The same thing applies here, that I can just say while true, which is like pretend will go forever, but then like obviously once we get to that specific point, we'll still escape the loop with a break. Okay, this person already used try parse. Yeah, that's pretty reasonable. And I'm actually going to rename this to count. So this is one of those things like I always hesitate to like, this is part of the thing about output parameters. Like they're a little complicated. Like the way I would do this is maybe that. No, I guess I can't do that because I got to use it down there, don't I? Like I'll usually declare my output variables in line. In this case, I can't, so I guess I wouldn't. Anyway, so I actually, if I'm not mistaken, I think at this point, this code all looks good. So depending on the thing, we'll add that. And then you purchase this, it tells us our updated totals. And then down here, so again, these are using the main methods variables. Maybe that's okay. Because the other alternative would be that we had to pass in those. And now we had to, like, that's passing in 1, 2, 3, 4, 5, 6 things, which is a lot. So maybe it's not worth it here. I suspect, and I'm not going to have time. I said 30 minutes and we're already at 37.5 minutes. I'm going to stop here, but like, I suspect there's a way you could refactor that still to like do something else. But anyway, I think because now here before the code that was here was just using the one variable, and now we're actually recalculating it. So I think we've actually accidentally fixed the bug that I saw. So let's give this a try and see where we're at. How many estates do you own? 4, 1, 5. Okay, what card do you want to buy? I want to buy 10 estates, which should bump up my score to 47. Yeah. So I think that's working. Like I said, I think this is a good example that if we did say, you know, don't use the main method stuff, like you can see like what all the stuff that we'd have to, it's really, there's a lot of red here, but it's really only, I think this is complaining about that method, but it's also complaining about all of these. And we could pass those. Perhaps if I had to, I'm not going to do it, but if I had to do it, what you might like, what I might do is I might turn this into a method and turn this into a method, and then like return those two things, and then just have the main method up, run this, and then let this code down here just be in the main method as well. Like I might do that. So it's just a different like factoring. It's just a different arrangement of the code. But anyway, we just explored a bunch of stuff here, kind of hopped around, kind of haphazard. Sometimes that's the way these code review videos work. Like I said, there's a lot of good stuff in here. It honestly looks like good code. The person who did this should be proud of themselves. It shows a good amount of effort here. Like I said, generally speaking, it's in pretty good shape. Hopefully some of those comments about like method parameters and return values and some of that stuff helps to make this a little clearer. Like I say, in terms of like intertwinedness, like if you're feeling that way, if you're feeling like this has become spaghetti and everything is touching everything, it's because these methods are all accessing the main methods variables, and that's allowed. It's fine to do it if there's a need or if there's a compelling reason. Like I said, maybe for these, the way this code is structured right now, it's maybe justified because otherwise I'd be having to pass in a lot of parameters, which you could do. 6 parameters, I've seen far worse. It's a lot, but I've seen far worse. But yeah, that's that. To the like I said, you want to know how to do it so that you can make a choice of, am I going to use the main method's variables, or am I going to just use parameters and return values? So you can make that choice from a place of not just, I don't know how to do it any other way, but rather from a place of, what is the correct choice for me right now? Like I said, this one didn't do it. We cleaned up some of these other ones so that they didn't have to do it. This one doesn't do that anymore. This one doesn't do that anymore. So the only method that's borrowing the main method stuff is this one. And so you can make that, you're allowed to make the choice of, I'm willing to let this method access the main method stuff. And that's fine. If you like, but again, you want to be able to do that because you had the skills to do it either way and you made an intentional choice, not because you didn't know what else to do. But all right, I spent 12 minutes longer on this than I meant to, so I'll stop now. But thanks for joining me. I hope these are useful, at least a little bit, and I'll see you guys.